All right. Hi everyone. I hope I am live. Let me quickly check. Yeah, looks like I'm live. That is good. Let me open my stream so that everyone can message and I can view the messages. Okay. All right. So things look good on the stream, and welcome everyone whoever is joining. To all the people who are watching the recording, you might be on YouTube right now, or if you're watching this after a couple of days, you can see it on Twitch. So yeah, that should be good as well. Right, so today's target is just to revise through hash maps. I think we did this in the last stream, but I'm just going to go through the tutorial over here. I mean, the book, right? Whatever the content is here. And let's just revise through whatever we missed, I guess. Right? I'm not sure if I did this right. I'm not very sure. All right. Yeah, I think we did dot iter and two iter, right? I remember all of that. Right, so that is what we're going to do today, and then we'll move on to error handling, which will be interesting and which is probably one of the most useful things in Rust. In any programming language, you should know how to handle errors and how to raise errors, especially something like Rust, where one of the plus points is the way they handle errors, right? All right, so here we have how to create a hash map. I think a lot of people already know what a hash map is, right? So we know that there's a key and there's a value, and they use a hash function to map all of them, right? So it's the mostly depending on what kind of hash function is being used, but unless until there's no collision and there's no complex thing happening, ideally, generally, or whatever you want to say, it is war fun operation, right? So if you have a hash map, if you just want to access the value corresponding to a given key, you can do it in WOF1 operation, right? So that is so hash maps are used a lot, right? Depending on the task you're doing, but I've seen them used a lot, being used a lot, right? So how do you get them into scope? You can do stored collections in hash map, and there you go. Then you can create your own hash map new constructor. So one way to create an empty hash map is using a new and adding elements with insert. Okay, so that's what we saw before as well. So you have let mute scores equal to hash map new, right? Again, remember that if you want to change anything in the scores, that means if you want to add, delete or anything, change values and all, you need to set it as mutable, right? Else by default it is immutable in Rust, right? Now you do scores.insert string from blue. That means the key is going to be blue, and it's of string type, it's not of stir, right? And then you have 10 and 50. So note that we need to first use the hash map from the collections partition portion of the standard library. Of our three common collections, this one is the least often used, so it's not included in the features brought into scope automatically in the prelude, right? So we saw about strings, we saw about vectors, but of course hash maps will not be used more than vectors and strings, right? So that's why it doesn't come in the prelude. That means you need to do it yourself manually, right? The hash map has keys of type string and values of type i32 over here, right, in this particular example. Like vectors, hash maps are homogeneous. All of the keys must have the same type, and all of the values must have the same type, right? So please don't get confused over here. This just means that if the given key for the very first element in the, I mean, there's no first in a map, I guess, but still, let's say that you first inserted blue comma 10, then the next whatever you want to insert, the next combination should also have the key as a string, right? And the value as a i32, right? Because that's what is the default type for integers, sorry. Like vectors, so we talked about it, homogeneous, right? Another way of constructing a hash map is by using iterators and the collect method on a vector of tuples. So what you can do is essentially you can have, let's say you have a string, right, of all the keys and of all the values. So you don't want to do dot insert key 1 comma value 1, key 2 comma value 2, right? So that's tiring for you. So what you can do is, let's say you have a key list, key vector and a value vector. Right now, as you can see that all of this is homogeneous, right? And what you can do is you can convert it into an iterator. So into iterator is a trait, I guess, in Rust, right? And then you can do dot zip. That means first you convert this into iterator, then you do into iterator for initial scores, which is the values, right? And then you zip both of them. That means whatever the first value in this team says is gonna correspond to the first value in the initial scores, right? So that is what zip does, right? I think we have, for those who are coming from Python will know about it. And then you do dot collect, right? So that's gonna convert it into the given type. So you have given this that you want a hash map out of it. So that's what it's gonna do, right? So this is what it does. Then we could use the collect method to turn that iterator of tuples into a hash map as shown in listing 821, right? So this is what it does. So the type annotation hash map underscore comma underscore is needed here because it's possible to collect into many different data structures, and Rust does not know which you want which you want unless you specify, right? So this type annotation is very useful here. So you can use .collect even, let's say if this was a 2D list, I don't know, different kind of data structures which will work for this, right? So .collect will work for all of them if you change this type into something else, right? So that's why you need to pass hash map over here just to specify that, oh, hey, I'm looking for a hash map here, okay? So that's what you're going to do. And hash maps and ownership. For types that implement the copy trait like I32, the values are copied into the hash map. For owned values like string, the values will be moved and the hash map will be the owner of those values. Right, so that's what it shows. So for example, field name, we have a string type now. Now this is an owned value, right? So this will not copy for you. So once this is done, then you cannot access field name and field value, right? So what you want to do probably is pass the reference, right? So if we insert references to values into the hash map, the values will not be moved into the hash map. The values that the references point to must be valid for at least as long as the hash map is valid, right? So if the hash map is no more valid, that means the address is not existing, right, anymore, and it will lead to some errors. So we will read more about lifetimes in chapter 10. So that's just leave it to that. So I think we have seen this. Now we can get a value out of the hash map by providing the key to the get method. So you can pass .get. I think it returns an option, right? Yeah, it returns an option enum, right? So what this does is .get it, because there is a possibility that the key that you're passing does not exist in the hash map, right? So it will return none in that case, and if it's found, then it will return of something of type sum, right? So that is good as well. So let me just zoom in since we are just only on this. We'll move to terminal once we are done. So you can see that here score will have the value that's associated with the blue team, and the result will be sum %10. The result is wrapped in sum because get returns an option. If there is no value for that key in the hash map, get will return none. The program will need to handle the option in one of the ways that we covered in chapter 6, right? So you can do match, you can do if let, you can do whatever you want, right? So we can iterate over each value or key pair in hash map in a similar manner as we do with vectors using a for loop. So you can do for key comma value in ampersand scores, and then you can just print whatever you want here. Yeah, that looks good, right? So that's how we will iterate. And sure, so updating a hash map. So we have just seen how to get some values for a particular key if it exists, right? If it doesn't, then it will return you none. So you can do match pattern for that. Now updating a hash map, although the number of key and value pairs is growable, each key can only have one value associated with it at a time. So looks like this hash map is stored in a heap memory, so that means you can keep growing, you can keep inserting keys and values, right? But for each key you will only have one unique value to it, right? So when you want to change the data in a hash map, you have to decide how to handle the case when a key already has a value assigned. You could replace the old value with a new value, completely disregarding the old value. You could keep the old value and ignore the new value, only adding the new value if the key does not already have a value, right? So overwriting a value, how do you do that? So for example, we have scores.insert. We already had this key blue, and then we do it again, but with a different value, 25. This time it will give you 25. So the original value of 10 has been written, so overwritten. That's what is the default, I guess. So only inserting a value. If key has no value, then you can do .or insert, right? So if the key has no value, that means you want to insert something, right? So that makes sense. So it's common to check whether a particular key has a value, and if it does not, insert a value for it. HashMaps have a special API for this called entry that takes the key you want to check as a parameter. Okay, so you have scores.entry, which takes the key as a parameter, and then you can do .or insert. So the return value of the entry method is an enum called entry that represents a value that might or might not exist. Let's say we want to check whether the key for the yellow team has a value associated with it. If it does not, we want to insert the value 50. So here we have yellow and here we have blue, and the same for the blue team. Now blue already had a value 10. So this time it's not going to insert 50 for you, but this yellow had no value because like there was no key called yellow over here, right? Yet. Now it just does that okay, it automatically understands, okay, I need to insert this key and I need to insert the corresponding value as 50. So the or insert method on entry is defined to return a mutable reference to the value for the corresponding entry key if that exists. And if not, inserts the parameter as a new value for this key and returns a mutable reference to the new value. This technique is much cleaner than writing the logic ourselves, and in addition, plays more nicely with the borrow checker. Yeah. So running the code and listening to will give you proper value. So let me do one thing, right? So let's go to our terminal, right? Mm, let's bring it here. It's kind of, yeah, much better. Okay. So what I want to do is, let's say cargo new sample, right? So let's go to sample and let's do vim src main.rs, right? Use std collections hash. What was it? Map, right? Hash map. So it has installed rationalizer, which is good. Unused import, that is fine. We will use it now. So what we can do over here is we can, let's say we have a hash map equal to hash map new, right? Type annotations needed. So why does it need a time annotation yet? We'll see. So yeah, we definitely want it map. Now map.insert. Okay, so it will understand once we start inserting, it will know what the type is. Because before that, it just can be anything, right? The key can be anything and the value can be anything as well, unless until you insert something. Now, let's say if I do string from Kush, and so that's my name, by the way, that's just a nickname. And let's say we want to insert a value, right? So we can probably do string from Kush. Do we have dot size, dot length, right? There you go. What happened? Why? Right, there you go. So we have inserted the length, right? Ideally, you could have. Okay, let's keep doing it. Sorry, this always happens with me in the stream. My throat chokes. That's my middle name, right? So that will do it for you. Now, what I want to do is, let's say if someone comes and says, okay, sorry, the length of Kush should not be the number of characters over here, but it should be probably the number of capital letters, I guess. We can say that, right? So if someone comes and says, it should not be this, but this, right? So this will work, right? But what if I say, we can do map.entry. If it exists, then you don't change it because you don't want to change anything if it already exists. And wait, what is wrong here? Dot or insert. I think it was this only, right? Or insert, right? That looks good to me. Map.entry. String. Oh, sorry, map. I'm doing insert here as well. My bad. Right, so this is good. Right, so if I now run this, okay, and probably I can just do print ln. How do you do this, by the way? Yeah, okay, colon. All right, so let's run it. Cargo, sorry, rust run. See, now it says Kush comma 4 and Ravi comma 4, right? So this is not changed. Dot or insert, right? What I want to do is I want to go to this entry source code, right? And you see rationalizer failed to load workspace, failed to write this, caused by failed to open. That is good, no issues. Now you see, so this return type is entry enum, right? And it has some lifetime here and k comma v, those are the key and values, right? Looks like a template. Let's go to entry. Can I go to entry? Probably we can do, yeah, I think it's here, right? So if I do this, there you go, pub enum entry, right? So a view into a single entry in a map which may either be vacant or occupied. So this enum is constructed from the entry method on HashMap, right? So that's only the reason. Okay, so this is the only purpose of this entry is, right? So we have map.rs and we have pub enum entry and occupied entry and vacant entry. So you have these two things, occupied entry and vacant entry. Awesome. That sounds good. And then they have impl for entry, and what are they implementing? Debug. Okay, debug. So they are implementing debug. Then they have occupied entry, all of these things. Yeah, we can skip that for now. Cool, this sounds good. Now let's look at or insert, right? How does it work? So let's look at or insert, right? So it just, yeah, there you go, right? That's what we're talking about. So it checks whether the self is occupied, an object of type occupied, or the enum value is occupied. Then it just converts into mutable. If not, then if it's vacant, that means the key doesn't exist. Then it's going to insert the key for you, and that's going to allow you to add the value as well. That's it. Sounds good. So I think insert. All right, all right, all right. That sounds good. So this is going to be the map, right? Yeah. And default is what? Default is the value you had. Is it? Is it? Okay. So they have insert with as well. I think we'll take a look at it later. But we have so many helper functions that we want to use. We have or insert with. We have or insert with key. If you want to pass a key as well, returns a reference to this entry's key as well. So if you want to access the key, it will return the reference, right? So that is all good, right? You have so many things that you can check and try to play around with. Ideally, I prefer to go through the source code and not through the documentation, because of course the documentation is usually generated from the source code. So it's just some added info that I like to have. But for those people who prefer documentation and just try to go through some examples, I think Rust documentation is great. So you can access that as well. Now, updating a value based on the old value. So suppose you have an old value already and you don't, we have seen it, right? Another common use case for hash maps is to look up a key's value, right? And then update it based on the old value. Okay. Map.entry word.or insert. You got the count. Then if you do count plus equal to 1, it dereferences. So it returns a reference to this value. If you do plus equal to 1, this will now be changed. Right. Okay, because see, the split whitespace method iterates over subslices separated by whitespace of the value in text, right? So sure, you will get hello, you will get world, you'll get wonderful, you'll get world again. The or insert method returns a mutable reference to the value for the specified key. Here we store that mutable reference in the count variable. So in order to assign to that value, we must first dereference count using the asterisk. The mutable reference goes out of scope at the end of the for loop, right? Because you do let count equal to this here. So all of these changes are safe and allowed for the borrowing rules. Sounds good. So yeah, I think we have seen about hashing functions. By default, HashMap uses a function called SIP hash that can provide resistance to denial of service attacks involving hash tables. Yeah, I mean, this is something very interesting, and I wanted to read more about it over my free time and then talk about it in a video. But for now on a live stream, I'll not read through it. Just know that a hash is a type that implements the build hasher trait. Hello, W Gafa. Hi, thank you so much for joining in here. And so it looks like you're the first viewer. I mean, first time chat. So thank you so much for joining in. So there's a message from him. Yay, Rust learning. Yeah. So I've been doing it for couple of 3 streams so far on Rust. I sometimes I'm like parallelly also working on an open source library called Bismuth. So it's a KDE tiling window manager. So I'm trying to port some code from TypeScript to C++ there. So I sometimes do that and sometimes I do Rust. And the end goal is to write a code editor, write an operating system, and write a deep learning framework in Rust. I think I missed something. I'm pretty sure I did. That's called compiler. So that's something that I also want to do. And there are enough resources about it, and there are great people who have done it already. But that doesn't mean that we should not do it, right? That's the whole goal. So yeah, that's the whole motivation of me streaming right now. And I hope that is enough for you to watch it as well. Please feel free to ask any questions if you have any. And thank you so much for joining. I'll appreciate if you want to follow. I'm on 48 followers, so I'll appreciate that. All right. So here we go. Let's talk about error handling now. So errors are a fact of life in software, right? So Rust has a number of features for handling situations in which something goes wrong. So in many cases, Rust requires you to acknowledge the possibility of an error and take some action before your code will compile. So this requirement makes your program more robust by ensuring that you will discover errors and handle them appropriately before you have deployed your code to action, right? So we all know what's the importance of errors and how should you handle them, right? So yeah, let's just try to understand them further. So Rust groups errors into two major categories: recoverable and unrecoverable errors. For recoverable errors, such as a file not found error, you most likely just want to report the problem to the user and retry the operation again, right? So sometimes it happens, right? So suppose I've been given a file, right? I have a utility function in my library that allows you to open that file, right? And if the file path is something which is invalid in terms that it doesn't exist in the file system, you just want to let the user know that, hey, the file path you mentioned doesn't exist, right? So there's no even like, you don't need to handle it separately, that okay, if it doesn't exist, create your own file. Maybe there's something that you want to do, but not as a user facing library, right? So if a user passes a configuration which does not exist, so those are like, you don't want to play around with that. So for recoverable errors such as file not found, right, so just want to let them know that okay, retry the operation, maybe you have just created a file, it's not updated yet in the file system, or something like that, right? So there are different possibilities that those errors can happen. Sometimes it happens, right? So a URL is down, so google.com is not opening, and then suddenly after 1 millisecond it's opening. So you can just retry, right? You can have number of retries, limits and all. Now, unrecoverable errors are always symptoms of bugs, like trying to access a location beyond the end of the array, and so you want to immediately stop the program, right? That makes sense, uh, because they will never exist, right? I mean, that is a bug. So you just want the users to know, hey, stop here. So most languages don't distinguish between these two kind of errors and handle both in the same way using mechanisms such as exceptions. Is that a pun to Python? Rust does not have exceptions. Instead, it has a type result t comma e for recoverable errors and panic macro that stops execution when the program encounters an unrecoverable error. Right. So they have recoverable errors. Oh god, that's such a hard term to pronounce. Then you have result, and that is an enum you have. And for unrecoverable error, oh god, we have a panic macro. So this chapter covers calling panic first and then talks about returning result. I think we have seen result couple of times. I hope that it's from the chapters only. Oh, what happened? Oh, sorry. Yeah. How can I? There you go. So now we have unrecoverable errors with panic macro. Sometimes bad things happen in your code and there's nothing you can do about it. Sure. So in that case, Rust calls this macro. We'll commonly invoke a panic when a bug of some kind has been detected and it's not clear how to handle the program at the time we are writing our program. Right? Makes sense. By default, when a panic occurs, the program starts unwinding, which means Rust walks back up the stack and cleans up data from the each function it encounters, right? Of course, right? So for example, you have a list. Okay, you have 10,000 elements in it. Okay, so that means you can just imagine number of bytes it will have, right? So the memory has been allocated and you get an error, so it will panic. Of course it will panic, but it's not like it will immediately stop the program before, without cleaning up the memory and whatever that was there. So it will go up the stack, okay, and it will start unwinding. So that's what the term they have used, which means Rust walks back up the stack and cleans up the data from each function it encounters. However, this walking back and cleanup is a lot of work. Rust therefore allows you to choose the alternative of immediately aborting, which ends the program without cleaning up. So Rust therefore allows you to choose the alternative of immediately aborting, which ends the program without cleaning up. Okay. Yeah, of course. So if you want to panic and you know that, okay, there's nothing to clean up, just abort. So you can do that as well. So memory that the program was using will then need to be cleaned up by the operating system. If in your project you need to make the resulting binary as small as possible, you can switch from unwinding to aborting upon a panic by adding panic equal to abort to the appropriate profile sections in a cargo.toml file. That makes sense. So it's now up to the operating system for them to clean up the memory because the process has been aborted. That means, it's not under the execution anymore. So depends on the operating system how they do that. So for example, we have function main panic crash and burn, right? So that's going to give you a stack trace as well. Main panicked at crash and burn src main.rs, second line, fifth character. The call to panic causes the error message contained in the last two lines. The first line shows our panic message and the place in the source code and where the panic occurred, right? So in this case, the line indicated is part of our code, and if we do go to that line, we see the panic macro call. Okay. right? So that's cool. That's cool. We'll discuss backtraces in more detail next. Okay. So using a panic backtrace, yeah, that's always useful, right? You want to know that, okay, what was the root for this panic macro, right? Where is it coming from? So let's look at another example to see what it's like when a panic calls from a library because of a bug in our code instead of from our code calling the macro directly. Yeah. So let's say we have this src main.rs and you have a vector of 1, 2, 3. So we do that using vector macro, right? And then we try to access the 99th index, which does not exist, right? So here we are attempting to access the 100th element of our vector, which is 99th index, right? Yeah, there you go. But the vector has only 3 elements. There you go. In this situation, Rust will panic. Using the square brackets is supposed to return an element, but if you pass an invalid index, there is no element in the Rust that Rust could return. That would be correct. So in C, attempting to read beyond the end of the data structure is called undefined behavior. You might get whatever is that location in the memory that could correspond to that element in the data structure, right? So So this is called a buffer overread and can lead to security vulnerabilities if an attacker is able to manipulate the index in such a way as to read the data that shouldn't be allowed to that is stored after a data structure, right? So that makes sense. So suppose you have a string called password, okay? You have, let's say, 1 2 3 4 over there. So that's a string of password, and in somehow the hacker is able to, like, figure out what's the memory location where this password variable, the memory is allocated for that variable, right? And if C allows you to access that memory directly, that is kind of unsafe, right? So that's what they mean, that there are security vulnerabilities that will happen. So to protect your program from this sort of vulnerability, if you try to read an element at an index that doesn't exist, Rust will sorry. So Rust will stop execution and refuse to continue. That is good. So this error points at line 4. We got it. The next note line tells us that we can set the Rust backtrace equal to one environment variable. So backtrace is a list of all the functions that have been called to get to this point, right? Just what a backtrace will mean. So backtraces in Rust work as you do in other languages. That is good. The key to reading the backtrace is to start from the top and read until you see the files you wrote. So that's the spot where the program originated. The lines above that spot are code that your code has called. So you can take a look at them and try to understand, okay, what might be the problem. Sometimes you're calling a third party library, right? And you don't know what's happening there. So you can print the backtrace and try to figure out and point out to a single function that might be the cause and just create a bug over there, right? So that's something you can do. Like, for example, you see, so you're trying to call that, it says src main.rs fourth line. Now just ignore whatever that comes in between because this is the line that we want to look at. Then you do vec.rs. Okay, so it's creating the vector. It's trying to, yeah, it's trying to get the index, get the value at the particular index, right? And then you can see this slice index generic type, I think, something like that, right? They have index function probably. Then they are panicking here. So you can probably stop here, right? And then try to figure out what's happening. So that's a lot of output. The exact output you see might be different depending on your operating system and Rust version. In order to get backtraces with this information, debug symbols must be enabled. So debug symbols are enabled by default when using cargo build or cargo run without the release flag. So these are the debug symbols, right? So if you use release flag, these will not appear, right? In the output, enlisting 9 to line 6 of the backtrace points to the line in our project that's causing our problem, right? So that is good. We'll come back to panic macro later on. So now we'll look at the result enum, I guess. That is good. Recoverable errors with result, okay? Now most errors are not serious enough to require the program to stop entirely. Sometimes when a function fails, it's for a reason that you can easily interpret and respond to. For example, if you want to open a file in the operation phase because the file does not exist, you might want to create the file instead of terminating the process. Yeah, I mean, depends, right? So let's say sometimes we do, right, this thing. I mean, I'm not sure if people, I'm pretty sure people use it, right? But mkdir-p. So what does it do, right? If the folder does not exist, it will create it for you, right? So sometimes you just don't want to raise the error, you just want to handle it the way you want. So recall from handling potential failure with the result type in chapter 2 that the result enum is defined as having two variants, OK and error, right? So this OK variant and error variant, ERR. The T and E are generic type parameters. Yeah, sure. So those can be anything, right? Depending on what type of I mean, whatever function that is giving this error. So we'll discuss generics in more detail in chapter 10. What you need to know right now is that T represents the type of the value that will be returned in a success case within the OK variant, and E represents the type of the value that will be returned by this error case, right? Because result has these generic type parameters, we can use the result type and the functions defined on it in many different situations where the successful value and the error value we want to return may differ. So let's, for example, we are calling a function here file open hello.txt and returns you, gives you a f, right, file. How do we know that file open returns a result? So we could look at the documentation, of course, or we could ask the compiler. So you can just access it and you can type annotate with U32 and it will raise an error to tell you that expected U32 found enum result. So from this it's saying that okay, oh yeah, U32 is expected, but no, this file open result gives you the enum result. I think so. If I'm not wrong in my, so let's do this, right? Or not even this, like for example in my vim neo vim setup, if I do shift k, it will tell you what the type is, right? Let mute map hash map string comma usize, because here we have string and usize here, right? So it will tell you all of that if you're using neo vim as well. So you need to just set up the lsp and it will work for you. So if you were probably just using the way they are using it here, right? So they're using file open and you need to do this, use, so let's try this, right? Use stdfs file. It also shows your documentation, which is pretty cool, right? Looks nice. I mean, essentially you're just trying to make it a VS Code, right? But it's something that I'm very used to, especially the key bindings and all. So that helps me. So let's say you have let f equal to file open and hello.txt. Now you're confused what's the type of f, right? So you can do shift K. Oops, sorry. Shift K. And it's going to give you, oh, so the output is result file comma error. There you go. Right? This helps. So if it is all okay, then the type is file. If it's not okay, then the type is error. Right? So that is good. So you can use that. Now this tells us the return type of the file open is a result t comma e. The generic type t has been filled in here with the type of the success value, which is stood fs file, which is a file handle. The type of e used in the error value is stood io error. So this return type means the call to file open might succeed and return a file handle that we can read from or write to. The function call also might fail. For example, the file might not exist or we might not have permission to access the file. The file open function needs to have a way to tell us whether it succeeded or failed at the same time. Give us either the value. Yeah, so it, okay, sorry, it's too much of English here. What it just means is it will be able to tell you two things. First of all, it will be able to return you the file handle if it succeeded. So that, there you go, you got two information, right? Whether it succeeded or not and what's the file handle. So in the case where file open succeeds, the value in the variable f will be instance of OK variant which contains the file handle. So in case it fails, it will contain the error variant. We need to add to the code. For example, here you can just to match f if it's of OK variant and you can just store that into a file. That means this file will be returned to f object, and error, if it's an error, then this panic macro will be called. Know that like the option enum, the result enum and its variants have been brought into the scope by the prelude. So it comes automatically. So we don't need to specify result before the OK and error variants. So when the result is OK, the code will return the inner file value out of the OK variant, and we then assign that file handle value to the variable f. Sounds good. And then you can run in cargo run and just check it panics here. Then you can match on different errors. You can have different kind of errors not found. If there's any other error, you can do that as well. So this error, I think, so okay, what this means is basically this error variant has dot kind function, which will return you of a different enum, and you can match it. If it is there, then you can create your own file. You can handle it accordingly. Sounds good to me. So there's an alternative. I think we have talked about it. Let f. No, this is different. Unwrap or else. I think let's not touch it now. Anyways, they're gonna talk about closures in chapter 13. So let's look at them now. Then only, right? Hey Venom, hi yaar. Guys, can you hear me properly? By the way, is my voice good? Can you guys hear me properly? That is the question. Yes, awesome. Sounds good. Goal is thank you so much for joining here. Thank you so much for all the people who are here, by the way. I'll appreciate if you guys will consider following as well, by the way. We are on 48 followers, so if you can reach to 50, that will be great. And if you have already followed, please do let me know. I don't know. I need to go to the channel and go to the stream manager and all. Right, so let's not waste our time now. So there are shortcuts for panic on error. There's one unwrap and there's then expect. So I already know about expect. I think we have talked about it here in this chapters. But let's still go through it, right? Using match works well enough, but it can be a bit verbose and doesn't always communicate intent well. Right over here, you saw what is happening, right? It's too much. So if error is raised, then you use match again to check what's the kind. If it's not found, then you use match again, because this file create is also going to return you result enum, right? So it's going to be again okay and error. So it's just really verbose. There's too much of code and it's too much for us to understand, right? So here we have unwrap and expect. The unwrap method is a shortcut method implemented just like the match operation expression. So if the result value is OK variant, unwrap will return the value inside the OK. If the result is error, unwrap will call the panic macro for us. So you can just do dot unwrap. I think it's unsafe, right? I've seen somewhere that you should not use unwrap, I guess. So if we run this code without the hello.txt file, we'll see an error message from the panic macro, which calls the unwrap method here. Similarly, the expect method lets us also choose the panic error message. Using expect instead of unwrap and providing good error message can convey your intent and make tracking down the source of panic easier. Sometimes it happens you cannot change the error message that is coming from the third party library, right? For example, here, if I do just file open hello.txt, so it says no such file or directory, right? Which is probably not the best error message you want. You also want to see, okay, what file was being opened, right? So you can see fail to open hello.txt. Now that's a better error message, right? So here you will be able to see, if you run this, you will see that error message. I think they have, yeah, there you go, failed to open hello.txt. So this is better, right? So we use expect in the same way as unwrap to return the file handle or call the panic macro. The error message used by expect in its call to panic macro will be the parameter that we pass to expect, okay, rather than the default panic message. By the way, the default panic message will also appear. It's not like that it will not appear, but the very first message that you will see is your message over here that you're passing in the expect call. Now, because this error message starts with the text we specified, it will be easier to find where in the code this error message is coming from. Now, if you use unwrap in multiple places, it can take more time to figure out exactly which unwrap is causing the panic, because all unwrap cause that panic print the same message. Yeah. So yes, using unwrap isn't usually what you want to do, but sometimes it's just justified to call it. Yeah. Yeah, I mean, of course, like sometimes it's just okay to call it, right? It depends what use case you have. I've seen people, like, for example, if you're building a library for a lot of users, for example, if you're trying to build a code editor, and let's say, like, for example, we do this here, right? If I do code space dot, right? What if this directory doesn't exist, right? If they try to do something like this, right? Should it create an empty file for you like this with this name, or should it not? So here you go. Like, for example, here they still opened the VS Code for you, and they gave this this tab a name of of whatever string you passed. So he's right. I mean, wgafa is right in the chat. It depends what kind of use case you have. Now you can also propagate errors. That means whatever error you got in this function, you can propagate to the different function. So when a function's implementation calls something that might fail, so instead of handling the error within the function itself, you can return the error to the calling code so that it can decide what to do. As I said, like, suppose now this VS Code is using another library which does this for you, whatever I did just right now. Now what that library did is, it didn't handle the error when the file path does not exist. It is upon VS Code to decide what the design should be. So this is a really good design, right? You propagate the errors. Okay, so here we got the error. Now take it and do whatever you want with it. Okay, you want to handle it, sure, do it. If you don't want to handle it, maybe just let the user know that the file path is incorrect. Now this is known as propagating the error and give more control to the calling code, where there might be more information or logic that dictates how the error should be handled, right? That makes sense. For example, here we are trying to open the file. Let mute f equal to match f. If it's okay, error. If it's error, you return here, right? So here it does not panic. Earlier we were panicking over there. Now we are just returning the error with the error variant. Okay, and we just pass whatever we had, E and E. That's it. Now you can do f dot read to string ampersand mute s if okay, yeah, this will not be called if there's an error, right? So that's all good. And you see it returns a result variant where it can either be a string if it's successful, and if it's not, then it's going to be of IO error type, right? That's what happens when this comes. So I think we don't need to read this all. The body of this function starts by calling. All of that is good. So instead of calling, they're just returning the error. So that is good as well. Yeah. Now, the code that calls this code will then handle the getting either an OK value or an error variant. So now it's upon the code, right? The pattern of propagating errors is so common in Rust that Rust provides the question mark operator to make this easier. Yeah, I think we have seen in println that we pass the question mark here. So for example, file open, this question mark. Now this is going to propagate the error for you. That's it. So it's that easy, right? So you don't have to write this all because it's so common, right? It's so obvious that you want to return the error. You don't want to panic immediately. So that's why they have given this question mark operator for you. So the question mark placed after result value is defined to work in almost the same way as the match expressions we define to handle the result values in the above listing. So if the value of the result is an OK, the value inside the OK will get returned from this expression, and the program will continue, right? If the value is an error variant, the error will then be returned from the whole function, as if we had the user return, have the return keyword. So that's exactly what it's doing. We saw. Okay, so there's a difference between what the match expression, okay, and this question operator does. Error values that have the question operator called on them goes through the from function defined in the from trait in the standard library, which is used to convert errors from one type to another. So when the question operator calls the from function, the error type received is converted into the error type defined in the return type of the current function. Okay, so here for example we have IO error. So that means it's going to convert the error type that we've got from file open to try and convert it into IO error. If I'm not wrong, we'll see. So this is useful when a function returns one error type to represent all the ways a function might fail, even if parts might fail for many different reasons. As long as there is an impl from and bracket whatever you want different error type for returned error to define the conversion in the traits from function. The question operator takes care of calling the from function automatically. I think they'll talk about it here. So here, so the question operator eliminates a lot of boilerplate and makes this function's implementation simpler. Hey, hi, Risk XY. Thank you so much for joining. Seeing you live after a long time. Hi, thank you so much for joining. Do, um, are you from my YouTube streams or are you from my Twitch streams? Because I've been streaming on YouTube for all this while. So yeah, but so good to have you all here, by the way, guys. And please consider following, guys. We are still on 48 followers. It's kind of a shame. But I don't know. Maybe my content is not that good to earn followers. But yeah, I'll appreciate if you can get to 50. But how have you been? So he uses NeoVim too. That is great, right? I'm your Twitch follower. Okay. Yeah. Thank you so much. Thank you so much. Yeah, I stopped streaming in between. I got really occupied and things were not good. But I'm so happy that I started streaming again. I've been doing Rust and trying to contribute to Bismuth, which is a KDE tiling window manager library. I mean, kind of an extension, not a library. But yeah, that's what I've been trying to do. By the way, I was probably going to end it here because this question mark thing is very important, right? And I don't want to do it in hurry. So I was just trying to wrap it up. We did a small, short 45-minute stream. See, because starting from here, things are gonna get complex. Like I mean, important as well. Generic types, traits, and lifetimes. I think each one of them will deserve one stream, right? Writing automated tests, sure, that's very important. Then IO project, what's happened? I can scroll it down. See, it's broken. My college started being offline. I don't get much time to watch Twitch nowadays. I'm in my third sem. That is good. I mean, it's good to be busy, right? That's what you all like. If you're busy, that's good. I hope that you stay busy. And I can understand that you don't get time to watch Twitch streams, which is great. I mean, that's okay. Okay, you can. By the way, I post all my I upload my recordings to YouTube. So you should, if whenever you get time, if you wanna watch them, you can also watch on my YouTube channel. Let me quickly link to my YouTube channel here in the chat. You don't like teachers? That's okay. They don't expect you to like them as well. They know, I guess. But yeah, I mean, what I would love is that there should exist one professor, you know, let me know if there's already one, who just lets you know, okay, guys, there's this syllabus, okay, this is what I'm gonna give in the end semester exam. Now there will be no lectures because anyways, whatever I will be teaching, nobody will understand because I don't teach, right? I just pronounce things in the slides and just do it yourself, right? Why waste 1 hour daily, right? 5 days in a week. So they are essentially wasting 5 hours. If you count assignments, that's plus two, plus three per week, per 2 weeks. And then their exams, just take exams, yeah. Like, anyways, people study themselves. I mean, students, right? Yeah, those teachers are here, yeah. I mean, they should be just out classes, right? I mean, I'm not saying that professors don't know stuff. All I'm saying is that, anyways, you expect students to study themselves. You can share slides. That is the best you can do because you have made them. Probably that's something you don't want to get rid of. So, yeah. And they earn money, and that's what I think most of the professors care about right nowadays. That's what I've seen in my short span of life, 4 years of BTech, 2 years of work experience, I guess. All right, guys. I think that was it. Whoever is here, please say hi right now. Now is a good time to say hi. If you want to chat about something, do that. Else I'm gonna leave. But I would like to know that who was here all this time. I think I've been doing this for long now, just to know that who is in my streams. And I would just like to remember those people who were there in this journey. So I hated maths till 12th, and then I saw a lecture on YouTube by a good teacher. Then I knew I did not hate maths, I hated a teacher. That's what Risk XY says. Yeah, I mean, you don't even hate the teacher, you just hate the way he teaches, right? Yeah, I can relate. I mean, there are times when I feel the same. When I used to feel the same. Now there's no teacher in my life. That is good. I wish there were mentors though. All right, guys. So that was it for today. Thank you so much for joining in. I think right now we only have Risk XY. What happened? Oh, sorry. I'm so sorry. What happened? Sorry. I'm so sorry. I'm so sorry, Risk XY. This Nightbot doesn't know how to correct things. I'm sorry. It was set to something default. All right. Thank you, guys. Thank you everyone for staying here. If you guys are here, please leave a message, say hi, and say bye. That is it for me. Consider following, guys. That is the best you can do. Of course, I am done with my stream today. This recording will go on my YouTube channel. So if you open my YouTube channel, I'm working hard. I'm working like really, really hard. I designed this banner for myself, for my channel. I mean, I have all these videos, all the live streams recorded here. So please feel free to subscribe, like the content, let me know whatever you feel. Yeah, and feel free to watch these shorts, right? Those are something good that I keep uploading. So just for fun, if you want to watch. I mean, these are not like literal shorts or TikTok type things, but those are good. So if you want to watch them, please go ahead and do it. All right, guys, thank you so much for joining. I think there are only two people here, Risk XY and W Gafa. Thank you so much for staying here. I appreciate that. I hope you like the stream. Take care. I'm gonna leave now and carry on my work. Take care, everyone. Thank you so much for joining in. Thank you again. That means a lot. It feels good that people are here. Feels alive. All right. Say bye, guys. Say bye so that I can leave. I don't have an ending. This fancy song thing that this song is gonna be played. 1, 2, 3. Stream ending type of thing. All right, guys. I will leave then. Take care, everyone. Thank you. Bye bye.